here's our review for the test. Let's just go ahead and jump right in. My suggestion, again, is to work a problem before you see the solution, just so you have a better chance of understanding the question. So, impulse and momentum. Momentum is mass in motion, or the quantity of motion. It's what it means to be in motion. All mass has motion. Impulse is a force applied over time. That's impulse and momentum. They're related in that impulse causes changes in momentum. So a better way to say it than they are the same is just that impulse is equal to the change in momentum. If I apply an impulse to an object, it's going to change the momentum of that object. The units for each, so momentum is mass times velocity. So that's kilograms times meters per second, mass, kilograms, meters per second, velocity. For impulse, you have force in newtons times time in seconds, so it's Newton seconds. The law of conservation of momentum says the momentum of a system will not change. So that means so if one object loses momentum, the other object is going to have to pick that momentum back up. It never goes away, it just transfers between two objects. When is momentum conserved? When the net force on the system is zero, or when there are no external forces. So, as long as that force is zero, the change in momentum for the system is going to have to be zero. All right, so for the airbag, passenger is still stopping. So the airbag reduces it reduces the force experienced in the collision, in the impact, by extending the time. All things considered, without the airbag or with the airbag, the passenger is going to experience the same impulse no matter what. So the airbag does not change the impulse. What the airbag does is change the force. It makes it smaller by extending the time. All right, here's our first kind of problem here. So, the dynamics cart has a mass of 3 kilograms. A student pushes the cart down the frictionless track. Okay, so for the top one, sorry, I went on too fast. So if the time goes up, the force goes down. Student pushes the cart down a frictionless track with a velocity of 4. Before it reaches the end, a string brings it to a sudden stop in a time of 1 second. So, change in momentum. So we have the mass is 3 kilograms. The initial velocity is 4 meters per second. The time is 0.1 seconds. We want to, when it stops, so the final velocity is 0. So if we want the change in momentum, that's going to be mass times change in velocity, or mass times velocity final minus velocity initial. Find these things on the pink formula chart. They're real helpful. So to get this, the change in momentum will be the mass, 3 kilograms, times 0, the final velocity, minus 4 meters per second, the initial velocity. That makes the change in momentum 12 kilogram meters per second. And it's negative. Find the average force. To find the force, I know force times time is equal to impulse, but I also know that impulse is equal to the change in momentum. So force times time is equal to the change in momentum. Force times the time of 0.1 seconds is equal to the change in momentum of negative 12 kilogram meters per second. So we divide both sides by 0.1. And that force comes out to be negative 120 newtons. The negative just indicates the direction. It's opposite the object's velocity, so it's stopping the object. All right. Question 5. We have a Hot Wheels car that's 10 kilograms, so that's our mass, traveling at 8 meters per second, that's our initial velocity, It experiences an impulse of 50 kilogram meters per second, and I want the new velocity of the car. That's our final velocity. So, on our formula chart, it's that big, long equation. We have impulse is equal to change in momentum is equal to P final minus P initial is equal to mv final minus mv initial. Again, this is on the formula chart. You need to know where this is. You need to know when to use it. Here we have an object, one single object, that's going to experience a force acting on it. So that impulse is negative 50, and that equals mv final, so 10 m times v final minus 10 the mass times v initial, 8. So negative 50 is equal to 10 v final minus 80. So if we move that 80 over, we get 30 is equal to 10 v final. So v final is equal to 3 meters per second. Number 6, same kind of question. I have a 0.4 kilogram marble, that's the mass. Goes initially with a velocity of 12 meters per second, that's the initial velocity. It experiences a force of 4 newtons, that's our force, for 3 seconds. I want to calculate the new velocity. Force times time is equal to impulse, is equal to change in momentum, is equal to P initial minus P final, is equal to mv final minus mv initial. We have this whole big thing. We know force and time, so we're definitely going to use that. And we want to find final velocity, so we have to use this last term, mv final minus mv initial. So we've got the force, 4 newtons, times the time of 3 seconds, is equal to the mass, 0.4 kilograms, times the final velocity, minus 0.4 kilograms times the initial velocity of 12. That's the equation we get from all of our givens. 12 is equal to 0.4 v final minus 0.4 times minus 4.8. Add 4.8 to both sides, so 16.8 is equal to 0.4 v final. Solve for v final, and we get 42 meters per second. 7, we have a collision. Because it's a collision, that means we have to do conservation of momentum. On impact, that means we have to draw our picture of the boxes. 2 boxes before, 2 boxes after. Inside of those boxes goes the mass of each object. So the first one's going to be 1,500 kilograms, mass 1. It's got an initial velocity of 15 meters per second. We need to write the velocity on top. Second box is for the second car. The second car has a mass of 800 kilograms. We're going to write that in. And it's traveling in the other direction with a velocity of 5 meters per second. So negative 5 meters per second. That's our second velocity. Afterwards, the cars lock up. What that means is they have the same velocity at the end. You could redraw it where they're touching. It really doesn't matter. What you need to know is that they have the same velocity. Well, the masses didn't change, so 1,500, 800. So once we do this, we're doing initial momentum before equals momentum after. The momentum before is mass 1 times velocity 1 plus mass 2 times velocity 2 equals the velocity at the end, mass 1 times its final velocity plus mass 2 times its final velocity. We have numbers for almost all those. So 1,500 times 5, that's mass 1 times mass 1's velocity. Sorry, 1,500 times 15. Mass 1 times mass 1's velocity. Plus 800 times negative 5 is equal to, at the end, 1,500 times v plus 800 times v. You need to be able to get that equation from this kind of information. If you can't do that, you need to go back and look at the solutions and the notes for conservation of momentum in collisions and in explosions. That's important. If you can't do this, you're not going to do so great on the test. But you have a lot of resources available to you. Now, mathematically speaking, I've got 1,500V plus 800V. I'm just going to add those two together. I have to combine them. When they stick together, we're going to combine the 1,500 and the 800. So 1,500 times 15 is 22,500 minus 4,000 is equal to 2,300 times V. So we're going to add that whole side together. 18,500 is equal to 2,300 V. Divide both sides by 2,300, and that velocity is 8.04 meters per second. Same kind of question. We have a collision. The two collide. That means we have to draw our 4 boxes. 2 before, 2 after. So the first box is going to be our first mass, 1 kilogram. And it's going with a velocity of plus 1 meter per second. It's going to hit a second cart, mass 2 kilograms. So we write that in the second cart. And that has a velocity of negative 0.5 meters per second. That whole side represents my initial momentum. If I wanted to get the initial momentum, m1v1 plus m2v2. Afterwards, it's still 1 kilogram and 2 kilograms. And it says the red cart, which had a mass of 1 kilogram, is moving with a velocity of negative 1 meter per second. And I don't know what the blue cart's doing. So we'll do m1v1 plus m2v2. That's the initial momentum, equals the final momentum. m1v1 final plus m2v2 final. Plug in all the numbers. So m1 is 1 kilogram, v1 is 1 meter per second, m2 is 2 kilograms, v2 is negative 0.5 meters per second. And that's equal to 1 kilogram times negative 1, m1 v1 final, plus m2, 2 kilograms times v2 final, which we don't know. That's the only thing we don't know, so we have to solve for it. So we got 1 minus 1 is equal to negative 1 plus 2v final. That 0 is equal to negative 1 plus 2v final. That gives me 1 is equal to 2v, and v is equal to 0.5 meters per second.